right. Hi, everyone. Thanks for coming and joining us for this webinar. My name is Pearl. I help out with marketing at Qnect. And today, Michael Gustafson, the Vice President of Strategy and Business Development at Qnect, will be your presenter today for this webinar. Also, if you have questions at any point during the webinar, please write them in the chat, in the Zoom chat. And we're going to leave some time for Q&A at the end of this video. All right, take it on, Michael.
Right. Thanks a lot, Pearl. And we're going to go through in about 30 minutes here, an overview of Qnect for Revit. We're excited about the launch of this new offering from Qnect. So we're going to talk about, what problem we're solving with this solution. What are the capabilities of the software? What support and documentation do we have for customers to, adopt this technology? And then where we're heading next. So for those of you who are not aware of what Qnect does, we're a team based out of Massachusetts that started over 10 years ago in developing steel, engineering software. You probably heard of a background in connection engineering, steel modeling, optimization. We really believe in the future of, helping the steel industry be more effective, more efficient in how it delivers and executes steel projects. The products we sell, we have develop and sell are both technologies built on Tekla, now on Revit as well, and that's what we'll be talking about today. And also we have services for structural engineers and general contractors for delivering connected steel models. But today we're going to be talking about our Revit offering that was just launched at Autodesk University last month. So the problem we're looking to solve with this is around RFIs. And we know that structural engineers face RFIs, for various reasons. One is the code of standard practice is becoming, more stringent on how engineers, even working in a delegated design approach with connection design, that they need to be better documenting, framing reinforcement areas, for example. That means like doublers and stiffeners in the framing, even if the engineer, as you are, you're not doing the connection design. And so that's one aspect that we saw was important to, develop in this product. And then also just generally with the RFI work process, engineers, we all face, RFIs that show up later in design. And that typically is because the fabricator, is uncovering these RFIs as they build their own 3D models and work through everything. But that really, throws a wrench into EORs, right? You have to refocus from current design work back to this project you did 6 months ago. And it just cuts into your efficiency. So what we're looking at is a workflow of what if you could discover and resolve these RFIs during design. The RFIs related to, impacted by the connection design, constructability, checking the quality of your 3D models, these type of things that show up generally later as steel RFIs. So the goal is to be able to streamline this process to make you, as an engineer, just have more time given back to you during the delivery process. And some of the surveys out there say that a typical RFI takes 10 days to go through the whole process. It's over $1,000 an RFI. I mean, all this impacts your bottom line. So the solution that we are delivering then is an app built inside of Revit that analyzes the steel frame, right? And so it looks at all the joints of the steel frames and identifies which ones can be connected and successfully connected for doing connection design or actually not. And we're looking at not just connection design, but actually fabrication, erection, all the aspects that go into the steel delivery. So the workflow of how this works as an engineer is, using Revit, right? You have your Revit models for delivering, you have the 3D model with the documentation, and we're reading the framing information. So the geometry, the material profiles, and the end forces too, if you have them in the model. There's really two ways that we can use forces. We can either use UDL tables uh, or shear tables that you have based on forces or number of bolts. These are typically the shear tables that you have on your general structural notes. So that's one option. Or you can actually extract them if you have them in the Revit model itself at the parameter ends, right? So we have really both options, a lot of flexibility for engineers to read forces. And the reasons we like to use the forces is because it can help you resolve a lot of issues and not overly complex connection designs that end up being an RFI later that come back to the EOR. So I'm going to show you just a quick how this works inside of Revit, so you just get your headspace around this. So this is a 3D model here in Revit. This is actually a good test model is in Revit's comes out of the box. It has this Snowden model. So it's actually a really good model to use. And what you'll see is a ribbon up here, this Qnect ribbon. And we really have these chronological steps here of what to do. Setup, which initially initializes the model. You export to do the analysis, you bring the results back, and then you review the results. And so the way it works is I typically suggest that you select like a part of the model and just to get familiar with the tool, right? You might look at a few nodes, you might look at a floor at a time, and that allows you to then investigate the information in the model. Now, when I ran that, I ran the export, and actually it automatically comes back with the analysis results. The coloring here, this is something I set up. Any user can do this because we're writing parameters into these members now. So like, for example, this beam or this beam right here, this W8 by 10, if I go in here, I can see analytical properties that were used to upload, and then the analysis results. These are Qnect results that we're bringing back into the model. And so I can see information in here, such as like, here's explanations of why the connection actually won't work. This is the classic W8 by 10 framing into a heavy girder. The cope is so large, it's flagging it to the EOR that connection actually will not work. And so those are the type of issues that are being looked at. You'll also see in the model here these little connection nodes. These are just placeholders, generic connections. They're not putting in the actual physical connection at this point, but more this is a connection object that Revit has in its product for you to kind of designate connection objects at a very kind of high level. And so we're placing those in the model. So that's like how the product works. And then to do the run, and then to actually manage the data, you have an interface here so that as you go through and you want to investigate, which connections were successful or not successful, I can come in here and, kind of investigate things as you go. So there's a lot of, capabilities here to, kind of dig into the details and go into those details of how to investigate the data in the model. So that's a quick overview of, exporting the results and viewing it in the plane. I wanted to go back to the presentation just to kind of go through what are some of the examples of workflows. And we're really excited about this technology because it really captures a lot of the knowledge that industry leaders like, Cliff Schwinger to Dave Ruby to, Michael West, Jim Fisher. These are guys who, when I was a young engineer, there was road shows going around the AISC, the nation, right? And young engineers, you would go around and watch these presentations, and these guys would talk about the lessons learned around steel. And what was interesting when Qnect started this, our technology over a decade ago, we've kind of learned through working with customers what are these constructability issues and these fit up issues, but a lot of these have already been documented for over 20 years by industry experts. So when kind of going through all these documents, I noticed, wow, we're really trying to capture a lot of these same issues, right? And we have over 30 million connection designs that have happened with our customers. So we're kind of capturing both kind of boots on the ground experience at Qnect with industry expert knowledge. the way that we're organizing this data is around really four different personas or stakeholders. There's the EOR, the connection engineer, the modeler, right, creating that detail. You could think of that as like the detailer even, and then the erector. But as a structural engineer, you're really interested in a lot of these different aspects because it's things around can you swing in a beam that's next to another beam that's less than 18 inches? Okay, if you design it that way, you need to be thinking about, well, what side is the connection going to be on to be able to swing it in, or other things related to like material grades if they're pertinent to HSS. I see a lot of engineers just making the Revit models all A992. Of course, if you're going to pass that model downstream to be used for quantity takeoffs or being useful downstream, it has to be really specific per the AISC edition. So the type of capabilities that we have then in the software are really then in three different buckets to do this analysis. Engineering issues. So this means we're checking things like member capacity checks. So is there we're checking the local limit state. So when you're putting, holes in the beams, right, for shear capacities or local buckling, looking at the connections themselves, of course, designing connections for shear plus axial moment. The forces being used, I mentioned earlier about using UDL or shear tables or the forces in the model. Some of those industry experts that I showed earlier, they have always touted, engineers should put the forces on their drawings. Otherwise, the connections are going to just be over designed. And so that's why we have that built in to read that data from the Revit model. The second bucket is around documentation, with engineers having to better document where doublers and stiffeners and these complex areas are in their framing that require reinforcement. Identifying those issues in Revit is actually going to be more efficient for you to document, to document those typical details, those non-typical details in your Revit model. And then finally, around constructability, we're checking things like dimensioning, accuracy, work points, material grades, and erectability. So now I wanted to just go through 4 or 5 examples then of how this works. So first on the aspect of identifying shear doublers and moment doublers, right? We know engineers, there are tools out there that you can analyze for this, right? Structural analysis tools. There's AISC has spreadsheets like the clean calm spreadsheets, but they're not really integrated into the BIM process effectively. So if there's a way to be able to identify these and resolve them, that's a win. So here in the Qnect for Revit app, I have a moment frame, right? And so we look at if you have the forces, moment capacities or moment forces in the model and the shears, it'll go through and analyze and design the connections. And even of course, if it successfully designs the connections, it lets you know which ones require stiffeners and doublers. And it'll tell you that information as well, like what's the sizes of all the geometry, all the details that go into the stiffeners and doublers. And this will help you take an action on this. Do you want to upsize the columns? Do you want to use a higher grade column? Maybe 65 or 80 KSI helps you resolve some of the complexities there. So those are the type of, that's the value of the data too, is not just documenting, but resolving them. The second example that I showed in the model earlier is the coping, at the top of steels. This can, really be an issue too when you have joists, right, where you have that extra offset for joist bearing. And so being able to look at these issues in a 3D model and resolve them are valuable to do. So, one of the ways you could be looking at this technology is helping train up young engineers on these best practices. With a lot of teams, working remotely now, it's hard to have that water cooler conversation with engineers to kind of train them up on these best practices. So you could kind of, this example here is a really great example of how to be able to do that. This example, another engineering example, is checking local limit states of columns. This is an example called out by the Rocky Mountain Steel Construction Organization as an issue that EORs have, where they design the framing, but the wall thicknesses are too thin on the HSS columns. Therefore, the connection is really complex. And so it uses, you need through plates or some type of expensive connection. So being able to identify these in the model is valuable. So Qnect for Revit will analyze and see, okay, I can do that type of connection, but the HSS column will fail per the AIC code for that limit state check, and flag that to you as the EOR. Then on the data accuracy, and this kind of falls in that bucket of constructability, where we look at things like work points. If the work points are not at the center line or in places that are just not typical, as shown here with the little yellow boxes, we will flag those in the model. I was working with looking at a engineer's model, and he had the work point, the Revit beam work point was just on the face of the web of the column, not at the center line. We're very detailed on this, right? Because if you sent this model to Tekla or SDS2, that type of information is very critical, right? Because everything is down to the details, right? When you're thinking about fabrication. Of course, engineers, you maybe don't need to have that flexibility. If you get these warnings, that's fine. You can ignore it, but we're just letting you know if you choose to pass this model downstream, or just being aware that your dimensions might not actually close on your drawings. It's good to be aware. I know when I worked as an engineer, and there's a lot of fudging you can do with dimensioning, right? And the building might not even close with the dimensions that you see. So if you can make sure it's all accurate, it helps you close the loop on your dimensioning. And then around erectability, we have different checks that we do around erectability and constructability. This is a check related to, fit up and swinging in of members, or if we have members you see stacked on top of each other, you want to be thinking about, okay, how are they going to be erecting these? Can the iron workers actually get in there and swing these in on top of each other? Do they have a place to stand? These are they're really telling you to be thinking about the sequencing and things here as an engineer, and have a dialogue even with your teams about how to resolve these issues. So that's a kind of an example of the different types of engineering, documentation, and constructability checks that we do. And I wanted to give you just a few hints then in terms of of getting started then with our solution. Like, what are some of the things to keep an eye out for? And there's really 4 different things that I wanted to highlight today in this webinar. One is the shapes and materials. Is when you're first running your models. I've seen some companies, they have their own, material naming conventions. Autodesk Revit has maybe 30 out of the box, right? We're mapping to those 30 plus. But if you have your own materials, that's fine. We just need to work with you to map those to the correct mapping, so that we're kind of moving, making sure everything is running through the system. And that means we're very sticky on things like HSS, right? HSS rectangular rounds cannot be A992, right? We're really following the AISC tables edition manual there on what the materials are. So that's the first thing to be cognizant of, and maybe require some interaction with us as you do your trials or explore the tool. The second is, from a workflow standpoint, I think it makes sense to study geometry by joints or by floors. And this helps you get a feel of the solution, right? If you upload the entire model, you have to analyze a lot of different data. You might have hundreds of joints that you have to analyze. If you can solve your issues kind of floor by floor, I think you'll see a pattern. Okay, if I solve them on the first floor, I go to the next floor, I know how to look for those same problems, and maybe you can solve those issues even before running our analysis tool. And the cool thing with our tool, this is number 3, is the members, look at the members being selected. So if you want to be thinking about the load paths, right? So if there's axial forces in your members, be selecting the members on the other side of the column, for example, because or the other side of two beams coming into a girder, because we want them to talk to each other, right? So make sure you're selecting enough elements so that the load paths can be resolved. And then the fourth I will say is on the forces. Yes, we're using UDL as a default. I know that's very conservative, but you can override those, right? We have two versions. We'll be talking about the versions like our Pro version allows all the customization possible to set up your own shear tables. Both products are Express, which is our entry level, and then Pro. Both will read forces from the Revit model. So you can always override any of the UDL settings by putting forces in the Revit model. So this is an overview of the actual products. We have, Express and then Pro. And I think what you'll see with Express, the biggest difference is, Express doesn't require any knowledge about Qnect's, we call them preferences, right? Everything is in Revit. You just get going and you just start using the product. The Pro, that's where you get the capability to go to our product. And so here I wanted to show just what that interface looks like. This is the Qnect, and this is the same interface with Qnect's Quick Connect that integrates with Tekla. It's basically the same cloud platform that integrates with Revit, but changing, setting up rules based on, the code, the building code, to using rules here. Just let me log in here. Using rules such as forces, right? Being able to set up the forces. Let me just go in here and select my forces here. Yeah, so if I go to forces under here, yep, I can pick LRFD, ASD. I can set up my shear tables here. A lot of flexibility, even things like connection types. If you wanted to run on, do I want to look at extended shear plates or just shear plates or just clip angles? We have defaults on that, but you have a lot of flexibility to go through and set up the preferences. And that all comes with the Pro capabilities. So to kind of close things off here, I wanted to talk about the support and documentation. We're really trying to, give as much information when you need it as you go when you're using this technology. So of course it's got the, when you hit F1 on any command, it's going to open help documentation. We have a lot of resources on the, on our website. You can actually go see it under qnect.com. You'll see support, videos, FAQs, all kinds of information there. So, but what we're excited about next is looking at how can we help you as engineers resolve these steel issues, but not in your own isolated box, and not just listening to what Qnect says, but looking at the industry experts, right? And so we're excited about building a platform with Autodesk through their group network to have steel industry information shared around things like constructability and best practices. It'll be a portal where engineers can dialogue and debate the best strategies to resolve these steel type issues, right? And we think this will be a great portal again for young engineers who are, it's work from home these days, maybe not as much water cooler talk. How can we use digital technologies to help engineers get this knowledge transfer it seemed like it was easier to do that many years ago. Now we just have to use other digital means to have that knowledge transfer. And then from a future roadmap, these are the type of areas that we're looking at investing in, around expanding the scope with more connection types, how to manage the issues with some type of issue management, usability, just informing the engineers just visually of how they're resolving their issues and their progress with resolving the issues. And then better documentation on, documenting on not just in the 3D model, but 2D drawings, right? So this means, we were looking at, different ways here. If we go into this 3D model, we're thinking of what are the different ways that we could be documenting this information. Where today we can put in things, we can annotate to the 2D drawings those same issues that we had shown in the 3D model. You can document those in the 2D world. What we're looking at in the future now is how can you document the doublers and stiffeners as well, and call those out so that you could identify, okay, I have certain doublers and stiffeners at these ends of members. How can we resolve those issues? So those are the direction that we're going from a documentation standpoint. Yeah, and here's just an example, a visual of what we do in Tekla today, we could do in Revit as well. Connection codes, flagging doublers and stiffeners, even having 3D visualization of connections. Really excited about that direction we're going and the feedback we've gotten. So just a call to action here with you is, yeah, download the trial. We got a 30-day trial available on the Autodesk App Store. Go ahead and explore it. And we'd love your feedback. And then we'd love for you also to, leverage both either the Express or Pro solution to discover RFIs. We estimate $1,000 for every RFI. I mean, that basically pays, one RFI pays for the software for a year. So we're excited for you to, start getting time back into your design process. And we will, if you're interested, we'll send an email after this too, if you want to sign up to receive an email about other activities to come, things such as the future updates that I spoke about, the Autodesk Group Network Community Hub, that will be, going live, sometime in the first probably quarter of next year. So with that, I think we're coming right up to the end of the hour, and see if there's any questions we can answer. Pearl?
All right. Well, so for right now, I don't see any questions. I don't think. I don't see any questions. I
All
would
right.
like to thank you, Michael, though. I thought that was a great presentation. I might be a little biased, I understand. But yeah, thank you very, very much for uh going through all of that. It's exciting. Um and of course, if anyone, so I'll be sending an email. Hopefully I have everyone's email addresses who have attended this. I'll be sending an email out, and it'll have, Michael's email, for example. So if you have follow-up questions, you can email him. And it'll have some other information that hopefully is helpful to you. All righty. I think that's it.
Thank you. Thank you, everybody. Thank you, Pearl.